Hi everyone, welcome to our next video about our MathChapter B on probability. Probability is a really important concept in quantum mechanics, and so we want a brief review of what basic ideas of probability and what we mean when we're talking about probability. And so one of the most important things to do is to define what we mean by probability. So say we have some event that we'll call J. This might be flipping a coin, and whether you get heads or tails. J could be heads. The probability of event J, we write as P sub J, is equal to some value between 0 and 1. So 0 means the event never happens, and 1 means the event always happens. And so we treat probabilities as fractions that are somewhere between 0 and 1. So, for example, if we have a coin, we could say that P for heads would be equal to 1/2, and P for tails would also be equal to 1/2. If we assume we have a perfectly balanced coin that gives us a 50-50 probability distribution. And so one property of probabilities, if we consider all the possible events, if we add up all of their probabilities, well, something has to happen. So all of those will add up to 1. So mathematically, we can say that if we take the sum over all of our possible outcomes, J equals 1 to however many possible outcomes there are, if we take all those probabilities, those should all add up to 1. And so this is just how we define probabilities, right? And so if we take, for example, right here, our heads plus our tails, we have to get either heads or tails. And so our total probability is 1, that we get one side of the coin or the other. One other property of probabilities, if we define things this way, it gives us a different way to find averages. And this can be useful when we're looking at a bunch of events, and we know the probabilities, but and the values associated with them. If we want to find average value, which we'll write with this bracket notation, x with brackets, these square brackets around x, this indicates an average. We can define this in terms of probabilities. If we add up the probability of getting event J times the value of event J, say if we're talking about heads and tails, if we assigned heads to 1 and tails to 2, something like that, for all the different J values that we have, that is our average. And so this is a different way to find our averages. So again here, x sub J is the value if event J occurs. So this doesn't quite work for the heads and tails, so we have to assign some values to the heads and tails, but same idea here. And so one other thing we can do with this, with probabilities, is often we're looking at something, so everything we've considered up to this point are discrete events. We have, say 3 different things that can happen, or 4 different things that can happen. Or if we're talking, say, a dice, we have 6 different sides of the dice that could be rolled. But when we're talking about things in quantum mechanics, we often look at what are known as probability distributions, where we're not considering just a bunch of discrete events, but a continuous range of possible outcomes. And so what we'll often write this as is it'll be some function where probability goes on the y-axis, and on the x-axis we have our variable of interest. So I'll just put it as x this time. And so this will follow some sort of curve like this. And so this probability distribution P of x, so the probability is a function of x, at a specific value gives the probability that probability between x and some infinitesimally larger dx. So if we kind of draw on here, right, this little sliver, the probability distribution tells us what's the probability of getting something within that very narrow range there. And so if we want to find a range, a specific range, we can integrate over this. So say we want to know what's the probability of something between two values of x, a and b. We would take the integral from a to b of our probability distribution, and that would give us the probability. So one final part of our probability distribution that's going to show up in several places in quantum mechanics is if we add up all the possible probabilities, similar to what we saw with the discrete probabilities when we're looking at probability distributions, this is also true. If we integrate over all the possible values of x, so negative infinity to positive infinity of our probability distribution, by definition, this has to add up to 1. And so this property of probabilities is something we're going to come back to when we talk about normalization. We'll explain what that means, and looking at quantum mechanical probability distributions. So that's our brief review of probability.